our inverse functions. So the beginning of our notes handout is just kind of a little refresh on when can we find an inverse, what is an inverse.
Teachers, pardon the interruptions, but we need to let juniors and seniors know that today and tomorrow prom tickets are of no cost if all your dues are paid. Underclass and out-of-town tickets are $25. Beginning Tuesday, April 16th, a $25 late fee will be added to the juniors and seniors ticket cost. Out-of-town and underclass will be $50. No exceptions, and you need to see Ms. Spalding before or after school or during advisory. Today and tomorrow, no cost.
Why is this announcement made during the middle of class?
No idea.
Like, this is an advisory.
Okay. So in algebra we talked about one-to-one functions, and what does it mean for something to be one-to-one?
They pass the vertical line test.
Oh, that's right.
They don't, the domain doesn't repeat.
If it's a function, the domain doesn't repeat. If it's one-to-one,
The domain and
the
the
range doesn't repeat. So together, that means that each x value corresponds to exactly one y value. Neither x nor y repeat. Now, if I'm just talking about my trig functions, if I think about sine, okay, if I graph sine from 0 to 2 pi, is it a function? Does x ever repeat? Not if we're just going from 0 to 2 pi, right? Is it one-to-one?
No, why?
No, the y values get repeated. So our trig functions, while they are functions, the x's don't repeat, they are not one-to-one. The y's do repeat. So if we're going to talk about the inverse, we can't deal with the whole trig function. The idea with an inverse is if I give you a y value, you can tell me one place on the graph that it corresponds to. So I could say 1/2, and you should be able to tell me a single time that sine inverse is equal to 1/2. But the problem with that is if I say 1/2, sine is equal to a positive 1/2 in quadrant 1 and quadrant 2, right? So in algebra we learned that it had to be one-to-one, so it had to pass the horizontal line test in order to find an inverse, which is what happens when you reverse x and y. When we are talking about inverses, x and y reverse, so the domain of the function is equal to the range of the inverse, and the range of the function is equal to the domain of the inverse, because they flip roles. We also know from algebra, since x and y are equal to one another, they are reflections across the line y equals x. Now, we're not going to go through a big long process of finding inverses for these, but I figured while we're talking about it, it's a good time just to review a couple things. So just side note, there's an ACT coming up, so just in case, if you have to find an inverse, remember that's when you write it as y equals instead of f of x. You flip the x and y values, and then you have to solve for y so you can put it back into function notation. So I think those are like fill in the blanks on your notes handout. So if you had to go through it in algebra, you change f of x to y, switch x and y, solve for y, and then at the very end you write it as f inverse of x. So we know that you found an inverse.
Is my crunching real loud?
Yeah.
Okay.
So what I said on here next was what I already talked about. The trig functions are not one-to-one, but I need to be able to find inverses. There's an inverse button on your calculator, and we've used it with some limitations. I was only giving you angles in the first quadrant when we did it, so that it all worked out. But now we need to be able to extend it. So you have sine, cosine, and tangent buttons. Above those you have sine -1, cosine -1, tangent -1. When we talk about our trig functions. We need two consecutive quadrants to graph our function in. One where you have the positive values and one where you have the negative. If you think about, let's say, the graph of sine. Okay, we know these are periodic functions. And so they just repeat over and over again. So I could graph sine. We did this back in chapter 4. Oh, that is a horrible graph.
See ours.
And we know it just keeps going forever and ever. Okay? If I'm looking at this, from here to here, this is like 0 to pi over 2. I hit all my positive sign values. If I keep going, is it 1 to 1? No. So if I want to get my negative values, I would have to go backwards. What quadrant would that be if you went backwards?
4.
Yes. So we pick two consecutive quadrants. Everything's positive in quadrant 1, so that's our positive quadrant. And then it'll either be 2 or 4, depending on when the function is negative. So sine inverse would exist in quadrants 1 and 4. 1 being the positive, 4 being the negative.
Isn't that 3?
Because this is like 0, this would be negative
Because 3 is tangent.
pi over 2. So if you think about like your graph, 0 to pi over 2 is here. 3 pi over 2 is also here. Okay. So you can think about it from the circle. If we're talking about sine, sine is the y values. So we need when the y's are positive and when the y's are negative. So quadrant 1 and 4. So inverse sine. Notation, you'll see y equals sine inverse of x. Or ACT really likes to say y equals arc sine of x. They both mean the same thing. With that, okay, the normal range of sine. So the possible values for sine go between -1 and +1. When you do an inverse, the range becomes the domain. So the domain of inverse sine is -1 to +1. When we are talking about inverse sine, okay, we need positive and a negative quadrant. So we said we're going to go from negative pi over 2 to positive pi over 2. So that becomes the range of inverse sine. So at the bottom of your notes packet, there is the graph, the points, and just showing you where we got those, and what you need to fill in. The domain and range, and then the single most important thing we are doing for each of these today is the quadrants. In what quadrants does inverse sine exist? And it's quadrant 1 for the positive and quadrant 4 for the negative. That is our emphasis on these. I put the graph up here for reference if you would like, just to kind of show you. I'm not really doing anything with the graphs. I gave you domain and range. I'm not really using that a lot. What I'm going to be relying on is the quadrants. So we know the two options when we're talking about inverses. We'll have some that are in quadrants 1 and 2. We will have some that are in 1 and 4. Sine inverse is 1 and 4. Let's talk about the next one. I guess I did put a few examples before I did the next one. So, talking about what this means. Because my problem starts with an inverse, I can only get a single answer. When I see arc sine, that's sine inverse, I know I can either have an answer in quadrant 1 or quadrant 4. What this means, the only way to move the arc sine over, this is basically saying sine of what angle is equal to 1/2. So an inverse is asking you for the angle. Now typically sine has multiple times where it can equal 1/2, but I've already told you it could only be in quadrant 1 or 4. In which of those quadrants is sine positive? Quadrant 1. Reference angle. When is sine 1/2? 30 degrees. Okay, so 30 degrees in quadrant 1 is 30 degrees. Or if I had said radians, you would say pi over 6. I could ask for either.
I don't like when your pen drops on your.
So, if the problem starts with an inverse, you can only get one answer. You're not telling me every time on the circle sine is equal to 1/2. You're telling me for that inverse function, the single time that it is 1/2. So if I said y equals sine inverse of -1, as soon as I see sine inverse, I know I can have an answer in quadrant 1 or quadrant 4.
It's negative so far.
Okay. This means sine of some angle is -1. Since it's a negative, that would have to be quadrant 4. Reference angle. When is sine 1? 90 degrees. Okay. So what would I call it? I mean, 90 isn't technically in quadrant 4. Here's 90, but sine is positive 1 there. Okay. So there's several different ways you could answer this. If you're dealing with degrees, you could call that 270 degrees. It's also, isn't that the same as -90? If we were in radians, we could call it 3 pi over 2, or 3 pi over 2 is -pi over 2. I don't care. Alright, just know if you're checking in the back of the book, they're going to give you the negative angles, but as long as you give me the coterminal, it doesn't matter to me.
What's the code? Oh,
The
that's when you have
pos-
plus 36.
yeah.
Okay.
So, I don't care. The problem would tell you if it were degrees or radians, you're not going to have to give both. But I don't care if you tell me positive 270 or negative 90. Alright, this one. Sine inverse of -2. So sine inverse can be in quadrant 1 or 4. It's negative, so that's quadrant 4. What I'm asking you is when is sine equal to -2? Okay, think about your circle. Sine is the y. When does y equal -2? Never. Can it be -2?
No.
No. So what's my answer?
And no solution.
No solution.
Ooh, are we allowed to draw it? Ooh,
Oh, I did my slash the opposite way as you.
no, that's right.
Gotta be different.
I always do it from the top left.
Alright. Have I lost anybody
No, but I can see
with me?
theory about it.
Okay, so let's talk about cosine. We know the graph of cosine, normal cosine, looks like this. Okay, and it would extend in the other direction as well. Oh, that's horrible. You guys know what I mean. So, here's from 0 to pi over 2. That's the positives. Can I keep going?
Yeah.
Yes. And we know that from our unit circle, cosine's the x. It's positive in quadrant 1, it's negative in quadrant 2. So I gave you all the information about cosine inverse. The domain is the same as the range of original cosine, so from -1 to 1. Because we're going with quadrants 1 and 2, that would be from 0 to pi. So you can fill that stuff in, but the really important piece that I want you to remember is cosine inverse is quadrants 1 and 2. If you don't remember anything else today, I need you to know what quadrants the inverse functions are in.
So, you heard it, but I didn't understand it until right now. Why does sine become negative?
In quadrant 4, so
Like, why can't we just keep going?
because in quadrant
S,
2,
S, S. It's all students. Okay. I've what's those called when they
And you had an epiphany?
enlighten?
I've been enlightened. Okay,
Oh, inverse cotangent. This is
so let's try some. If I tell you, find y, where y equals arc cosine of 1. Okay, as soon as you see a problem with arc cosine or cosine inverse, it means the same thing. I want you to write down what quadrants it can be in. Okay, your options are either be 1 and 2 or 1 and 4. You have to have a positive quadrant, which is 1, and a negative quadrant. When is cosine negative? 2. So it can be either a quadrant 1 or a quadrant 2. Are we dealing with a positive or a negative?
positive.
Positive. So we would have to be in quadrant 1. Alright, so the meaning of an inverse, it's saying cosine of y is equal to 1. Okay. So because the problem started as an inverse, you can only give me one answer. I need a single time between quadrants 1 and 2 when cosine is equal to 1. 0 degrees. Or 0 radians.
I have a theory about this next one. Oh, would you write 0 radians?
Just 0 with no unit on it.
Because it's negative this next one. Doesn't that?
Okay. So, as soon as I see cosine inverse, I know I'm only going to get one answer. Please write down your quadrants. In what quadrants does cosine inverse exist?
1, 2.
1 and 2. If you remember nothing else today, you have to know that. Because this is a negative, which quadrant am I in?
2.
So this means cosine of some angle is equal to negative radical 2 over 2. Reference angle. When is cosine radical 2 over 2?
45 degrees.
So, 45 degrees in quadrant 2 is,
135.
or if I had said you were in radians,
3 over
3 pi over 4. So I would specify in the directions if it were degrees or radians. If I didn't, you could give me either. You can't because that would be in quadrant 4.
Maybe I'm just silly. How did we get 135 from 45? Is it 180 minus 45?
Mhm.
Okay.
All right, you guys try this one. What quadrants can it be in?
1, 2.
It's a positive 1/2, so we're in quadrant 1. So I'm asking you, when does cosine of y equal 1/2? Give me the angle on the circle when cosine is 1/2. 60 degrees, or if I said radians, that would be pi over 3.
1/2. It's it's bottom of it.
Mm-hmm. All right. Let's talk about the next one, tangent. So when we graph tangent, so if it helps you remember, we do have a handout somewhere with all the graphs on there. But tangent looks something like this. Right? And when we look at that, we also know it could go
I thought it was like,
cotangents. Flipped, it's increasing. Tangent is decreasing.
Where are all your graphs sideways? Drawing me
Because it's inverses. Once the x's and once it's
out. Oh, I understand.
okay. So we know we need two quadrants. A positive and a negative. Everything's positive in quadrant 1. So we could either do 1 and 2 or 1 and 4, right? When we graphed tangent originally, does anybody have that graphing handout back from chapter 4?
I got it somewhere.
Remember with tangent and cotangent, we picked some different intervals for them? And so, when we did our tangent, get a nice smooth section of our graph. So, technically, tangent is positive in 1 and it's negative in both 2 and 4. The way it's defined is that tangent inverse is quadrant 1 and 4. And that goes back to how when we originally graphed it, we went from negative pi over 2 to positive pi over 2. So that's why it's going to be 1 and 4 now. All right, so tangent is like sine. 1 and 4. 1 is our positive quadrant, 4 is our negative quadrant. Cotangent. When we graphed that, if you look back at your handout that we did in chapter 4, it started with an asymptote and we had normally graphed it from 0 to pi. So cotangent is going to be quadrants 1 and 2. And the other information I'm giving you, domains and ranges, we're not really going to focus on that, but I went ahead and put it up there as we were going through, just as a reference. Secant and cosecant, remember when we graphed those, we did the sine or cosine first? So they're going to follow their reciprocal. So when we did secant, secant is the reciprocal of cosine. Cosine was 1 and 2, so secant will be 1 and 2.
Oh, this domain is different.
Because it has an asymptote in the middle. And cosecant is the reciprocal of sine. So it will be the same quadrants as sine inverse. So that will be 1 and 4.
Whoever's out in the hallway just read my mind.
Wait, can you repeat what you just said?
Yeah, I'm getting ready to switch the slide and write it down. Okay, you guys have secant down? And then cosecant is like sine.
So quadrant 3 is just where the
Quadrant 3 we will never use for an inverse.
Oh, quadrant.
So you have to watch it three times.
You're welcome. Alright, so that's what you need to know. Okay, I gave you a lot of background, but we're hitting the highlights in this section. What we need to know is what quadrant our answer can exist in. We can only get one answer. So now we're just going to practice some problems. Okay, if I want to find the degree measure of the following. Theta equals arctan of 1. Arctan is tangent inverse. What quadrants can tangent inverse be in?
1.
In which one would it be a positive? So what this means is tangent of some angle is equal to 1, and I have to give that angle in quadrant 1. So when is tangent 1? 45 degrees. Okay. Secant inverse of 2. Secant inverse is the reciprocal of cosine. So which quadrants can we be in? If it's a positive, we're going to be in. So this is saying secant of some angle is equal to 2. So you're basically in quadrant 1 from your unit circle. When is secant 2? Another way to think about it, if secant is 2, what's cosine? When is cosine 1/2? Using the calculator from these can be tricky. And here's why. Okay. We don't have buttons for secant, cosecant, and cotangent, right? So we have to use sine, cosine, and tangent. Here's the thing. Tangent inverse and cotangent inverse are in different quadrants. So if you're looking for a cotangent inverse of a negative angle, but you have to use the tangent button, it's going to give you the answer in quadrant 4 because tangent inverse is in quadrant 4. But is that what we were looking for? No, we need the one in quadrant 2.
Wouldn't you have to just do cosine or sine?
With inverses, it's a little more complicated. So what we're going to do is use reference angles. So never enter the negative angle. I'm always going to ask you, give me the positive, do the reference angle, and then we'll place it in whatever quadrant we need. And that way you don't have to remember, oh, for this function, my calculator is going to give me the right answer, and for this one, it's going to give me the wrong answer. We're just going to do it the same way every time. So, we're only going to rely on our calculator if it's one we don't have memorized. You know, our standard ones from our hand trick or our unit circle we should know. If I ask you to find y, if y is equal to cosecant inverse of -3. Okay, cosecant inverse can be in which quadrants?
1 and 4.
Alright, if it's negative, we're in quadrant 4. Do we know when cosecant is equal to 3? No. So I'm going to ask you to get a reference angle on your calculator. And to do that, you are going to we need the cosecant inverse of the positive. Except, do we even have a cosecant button? No. So we have to really think about how we're going to type this in. So let's think about this. That means that cosecant of y is equal to -3. That means sine of y is equal to, so our reference angle, we are going to do sine inverse of +1/3. I asked for radians, so make sure you're in radian mode. And then we do sine inverse, so second sine of 1/3.
We just drop the negative.
Yes, for now. We're just doing the reference angle. So that's our reference angle. How would you put that in quadrant 4?
You have to subtract 2 pi.
You do, in quadrant 4, we always do 360 minus our
360
angles,
minus-
but we're in radians, so it would be 2 pi
minus.
that angle. So 2 pi minus 0.3398.
My decimal.
We get 5.9434.
So is it always going to be 2 pi?
If you're in quadrant 4, yes.
You want to stick to ones we know, like on our hand, please?
I don't remember. Do we add, if we're in quadrant 2, we add?
You do pi minus, because it's always distance from the
Right.
x-axis.
We subtracted 2 pi minus 0.33.
Do we have it? Let's try another one.
I'm sure.
Alright. Find theta in degrees if theta equals arc cotangent of -0.3541.
Change that calculator.
Cotangent inverse can be in which quadrants?
1 and 2.
Which one are we in?
2.
So what this means is cotangent is equal to a negative 0.3541. Is everyone with me?
It's cotangent inverse, right?
It was, but when I moved to the side, cotangent of that angle is equal to this. We don't have a cotangent button, so that means tangent is the reciprocal. But if you type in tangent of this, you will get the wrong answer. We have to do the reference angle. So my reference angle is going to be tangent inverse of the positive. And switch it into degree mode because I said degrees. Make sure everybody's typing this in correctly and getting it to work out. Okay, so what quadrant do we need? How do we put that in quadrant 2?
Subtract the top.
We're in degrees, so it'd be 180
180.
minus.
I was really confused on how you were writing on the board with just your hand back there.
Oh.
She's a wizard, Harry.
Why did you
I'm
make
pretty
it
Positive and turn it into a fraction.
Because I was finding my reference angle. So the reference angle is always the positive. If you had typed it in as a negative, you would have actually been given an answer in quadrant 4, which is not the quadrant we want. So always do the positives. That's your reference angle. Put it in the angle you want, or in the quadrant you want. All right. I am going to look at these last two to wrap up for today. And tomorrow we are going to have some time to work and probably also do a couple more examples.
Pardon me, what is it?
Okay, without a calculator. So, sine of tangent inverse 3/2.
We solved tangent first.
So, an inverse is basically finding an angle. Do we know when tangent is 3/2? No. But I have to find out what sine of that angle is, and I told you can't use a calculator. So what this means is that tangent of some angle is equal to a positive 3/2. Tangent inverse could be in which quadrants?
1, 4.
Which one are we in?
1.
1, because it's positive. Alright, so if you think about in quadrant 1, tangent, SOHCAHTOA, opposite over adjacent, is 3/2. So we can find our missing side. 2 squared plus 3 squared equals c squared. So our missing side is the square root of 13. So sine, SOHCAHTOA, opposite over hypotenuse, be 3 over the square root of 13, which is 3 radical 13 over 13. Did we ever actually figure out what the angle was?
No.
No, but we didn't have to because we had the information to make our triangle, and we were just asking for sine, a ratio of those sides.
Will you make me draw a triangle out? If I can just
As long as you
write,
don't mess up.
if I can write the Pythagorean theorem out.
As long as you make sure your sides are right.
I just always draw the triangle the wrong way and it screws me over.
All right.
Oh.
What? So the answer to an inverse is just an angle. I'm asking you to find tangent of some angle. Cosine inverse can be in quadrant 1 or 4. Which one are, sorry, 1 or 2. Which one are we in?
2.
So, in quadrant 2, This means cosine of that angle is negative 5 over 13. Here's my cosine is adjacent over hypotenuse. A squared plus b squared plus c squared. So tangent, opposite over adjacent, 12 over negative 5. Negative 12. So this stuff kind of goes back to knowing your unit circle. You have to know which quadrants your answers are in, and then you have to know your angles on your unit circle. We will probably do a few more sample problems tomorrow. We might add some on the back of the notes if we're struggling. You will have some class time tomorrow as well. Okay, so I might do, towards the end of class, a brief bit from section 6.2, but the majority of class tomorrow will be spent going over some of this, working on it, answering questions. Okay, so you can start, but don't feel like you have a pile of homework you have to do tonight. We're going to work on it tomorrow as well.
I kind of